Hey guys, Mrs. Ullrey.
Mr. Sanford.
All right, what we're going to do is we're going to go over the analysis questions from our lab from the other day, the M&Mium. What we want to point out is we're going through all the learning targets that are going to be on your test, which is coming up on Friday. So the first one we're going to go over is learning target 222, which is identifying a piece of lab equipment. So it says, which tool did you use to find the mass? So the mass is our keyword. Anytime you're going to try and find a mass, we're looking for an electronic balance. This guy right here.
Nice. All right, guys, we want to figure out what the purpose of this lab is, so we need to think back to that intro, the investigation, and what we did. So we measured mass, and we calculated the percent abundance, and all of that was to find the average atomic mass of M&Mium, our made-up element, right? Those isotopes of M&Mium. To find that average atomic mass.
Okay, so 231. What we want to be able to do then is, when finding the mass of a single type of M&M isotope, why did you measure the mass of all the M&Ms of that type as opposed to measuring the mass of just one? So this is talking about how does our procedure relate to our purpose. So this is a 3.0 learning target. So the whole reason that we did that is there's variation in size to each variety of our M&Ms, right? So caramel M&Ms is a different size from pretzel, but even within the type, there's variation. So not all of the caramel M&Ms are the same size. Not all of the pretzel M&Ms are the same size. So by taking them as a group, you can eliminate some of that error for having that variation of size.
So question 4, learning targets 224 and 234, we need to make a conclusion and then justify that conclusion. So we were asked which isotope of M&Mium was most abundant, and we need to justify it. So we're going to say the regular M&M was most abundant. Regular M&Ms, or the plain M&Ms, had the largest percentage of M&Mium, and they accounted for 55.6 of all those isotopes. So the largest percentage is always going to be your most abundant.
Then another thing that you're going to have to do is calculate percent error. We did this in our very first unit, right? That was one of the calculations that you had to know. And we told you that you would be seeing that for the rest of the school year. So here it is. The big thing that you just need to know when calculating percent error is, what do we mean by measured? What do we mean by accepted? Measured is something that you actually measure in class. So we measured the mass of a regular M&M. Accepted is what it should be. So it says the Mars company, which is what makes M&Ms, said that a regular M&M should weigh 1.13 grams. However, when we actually did our lab, we discovered that the mass of our M&M, our regular, was 0.98. And then we subtract our accepted, and then we divide it by our accepted, which was 1.13. Then we need to multiply it by 100, and when we do that, what we're going to end up getting is negative 13.3. And that's because our measured mass was smaller than our accepted.
All right, guys, so we also need to interpret that percent error. So your results are considered accurate if your percent error is less than 5%. So and we need to propose a logical explanation for that percent error. So our percent error was negative 13%. So that's pretty far below the accepted value. So we need to propose a logical explanation for why that happened. And we can say that the results of this lab are not accurate because percent error was larger than 5%, right? Even though we're negative, we're still more than 5% away from zero. So the mass of our regular M&M was 13.3% smaller than it should have been.
Please be careful with this learning target. There's two parts to this learning target. You need to interpret your percent error, which is what this first statement is. Interpretation is telling whether or not your results were accurate, and that's that 5% rule. So if your number is greater than 5%, and it doesn't matter positive or negative, you're going to say that your results were not accurate. So we say the results of this lab was not accurate because the percent error was larger than 5%. And then you're going to interpret the positive or negative. So it was negative 13. What negative means is that the mass of the M&M was 13% smaller than it should have been. So this is the interpret part. And then at the bottom, the second part, it says propose a logical explanation for what caused that error. So this may have occurred because our sample of regular M&Ms may have contained more of the smaller size M&M variation. So we may have just accidentally grabbed more small M&Ms than the large M&Ms, causing our mass to be smaller than expected.
All right. Learning target 245, a 4.0 level. Explain how this error in a specific measurement affects the results. So let's talk about how the error in the mass of one of these types of M&Ms affected the average atomic mass for all of the M&Ms. Well, since it was smaller, right, the mass of the regular plain M&M was smaller, and it would cause the average atomic mass to be smaller than actual. Right? So meaning like that the mass of the average atomic mass was closer to that mass of the plain M&Ms than it should have been.
Yep. All right, guys, that's analysis. See ya.
Bye.